unstructured. It's the wild, untamed, messy majority of information out there. The best way to think about it is to imagine all that data is just a hopelessly messy room. I mean, you can't just stand there and throw your hands up, right? No, you'd start sorting. And in the world of data, that sorting process starts by making 3 really big piles. So that first giant leap towards organization is separating the neat and tidy stuff from all the wild, creative clutter. This is the great divide between what we call structured and unstructured data. On one side, you've got structured data. You can think of it like a perfectly organized filing cabinet. Everything has a very specific spot in a nice, neat row and column. But on the other side, you have unstructured data, and that's more like a giant overflowing box of old family photos, vacation videos, and saved voicemails. There's no predefined format, it's just a huge collection of rich, complex stuff. An online order? That's a perfect example of structured data. See how you have these really clear fields like order ID, name, and date? The data just fits into them perfectly. This makes it super predictable and incredibly easy for a computer to read and analyze. But then you've got something like a social media post, and wow, it's a whole different beast. You've got an image file, maybe a video, some text, user tags, location data, likes, comments. They're all related, sure, but they don't fit into a tidy little table. This is the kind of data that really runs the modern internet. And of course, it's not always so black and white. There's a middle ground. We call it semi-structured data. A classic example is an email. It has some organizational tags, the to, the from, the subject, but the actual body of the email, that's just completely unstructured text. This is our third pile in that messy room. Okay, so we've sorted all our data into piles. Now what? Where do we actually put all this stuff? Well, this brings us to the idea of databases, the digital libraries that are built to hold all of our information. And when it comes to databases, there are really 2 main camps. First, you've got relational databases. They're like those traditional libraries with the meticulous card catalogs, absolutely perfect for our neat structured data. But for all that messy, unstructured stuff from the internet, you need something totally different. And that's where non-relational or NoSQL databases come in. Think of them like a flexible digital archive, built to handle massive amounts of different kinds of data without needing a rigid structure up front. So what makes those traditional databases so incredibly reliable? Well, it comes down to a super strict set of rules that we call ACID. It means every transaction is atomic. It's all or nothing. The data has to stay consistent and valid. Different transactions are isolated so they don't mess with each other. And finally, the system is durable, meaning once your data is saved, it is saved, even if the whole system comes crashing down. But how do these databases pull this off? How do they stay so perfectly organized? Let's get into the secret sauce that makes them so efficient, something called keys and a process called normalization. The magic really starts with the primary key. All you have to do is think of it as a totally unique ID for every single entry in a table, kind of like a social security number or a student ID. This makes sure that you can always find the exact record you're looking for with zero confusion. And that whole idea of giving everything a unique ID, well, that's the foundation for a really important concept called normalization. The goal here is super simple. Eliminate redundancy. Storing the same information over and over again is just inefficient. And frankly, it's just asking for trouble. Okay, look at this messy table here. You see how Susie Baker's name is repeated for each payment? It's a waste of space. And what happens when a third payment comes in? Do we have to add a whole new column? This is just inefficient and messy. This is what we call a denormalized table. So how do we fix it? The first step in normalization is to give each type of information its own home. So we create a dedicated table just for the students. Boom. Susie Baker now exists in only one place. Much cleaner, right? This is what we call the first normal form. Next, we create a second table just for the payments. Each payment gets its own unique ID, but, and here's the clever part, it's linked back to the student using their student ID. Now we can add 1 million payments for Susie without ever repeating her name again. The data is clean, efficient, and perfectly connected. Okay, let's zoom in even further now, down to the most fundamental level. Inside every single field in our perfectly organized tables, the data itself has a specific identity. You can think of it as the DNA of data. You see, every single piece of data gets categorized. A person's name, for instance, is a string of text. An amount of money that you can do math with is numeric. An event has a date/time. A simple yes or no question, that's a Boolean. And even those huge files like photos are stored as large objects. Defining these types is absolutely critical for the whole system to work. And you can see it all in action right here in this simple user profile. The user ID is a number, the name is a string of text, the join date is a date, and their premium status, well, that's just a simple true or false Boolean value. Every single field has a specific data type assigned to it. So we've taken this whole journey from just a chaotic mess of data to these highly structured, beautiful databases. But so what? Why does this hidden world of organization matter so much to you? And here's why it all matters. This structure, the tables, the keys, the data types, this is the invisible engine that is running your entire digital life. It's what makes sure your bank balance is correct. It's how your online order gets tracked all the way to your door. It's the reason your favorite apps are so reliable and so fast. This underlying order is everywhere you look. So the next time you use an app or buy something online, think about the data, the tables, and the keys working tirelessly behind the scenes. Now that you can see the structure, what new patterns are you going to start finding in your own digital world?
All right, let's pull back the curtain on the incredible and often invisible world of data systems. Over the next few minutes, we're going to follow the journey your data takes. Yep, from a single click on your phone all the way to a massive business insight. Let's dive in. So think about it for a second. Every time you buy something online or grab cash from an ATM or even just post on social media, you're creating data. But it doesn't just, vanish into thin air. It goes on this wild ride through some seriously sophisticated systems that are designed to capture it, store it, and eventually make sense of it all. So let's follow that trail. To really get this, the first thing you need to know is that data systems kind of have split personalities. Seriously. There's one personality for handling things that are happening right now, and a completely different one for looking back at everything that's already happened. And here's that fundamental divide right here. On one side, you've got OLTP. This system is lightning fast, built to handle thousands of tiny transactions every single second. It's like the digital cashier at a supermarket, just scanning and processing, boom, boom, boom. Then on the other side, you've got OLAP. This is the heavyweight analyst in the back room, poring over mountains of historical data to find hidden trends and ask those big picture questions. The ATM is just the perfect example of OLTP in action. You take out cash, and that system has to record the change to your balance instantly. It's all about speed and accuracy right in that moment. You definitely want your balance to be correct right away, don't you? This leads to a really good question. Why not just use that super fast live system for everything? Well, if you try to ask that OLTP system to analyze an entire year's worth of sales, it would just grind to a halt. It's kind of like asking a world-class sprinter to suddenly run a marathon. It's just not what it was built for. And that creates a huge problem for businesses. And the problem gets even bigger, because it's not just one system we're talking about. Most companies have their data locked away in all these separate digital vaults. You've got sales over here, finance over there, HR in another corner, and none of them are talking to each other. We call these things data silos. Just picture it. Sales data is in Salesforce. Employee data is in Workday. And the financials? Oh, that's in some other accounting system. So a seemingly simple question like, hey, who are my top performing employees and what did they sell last quarter? Becomes almost impossible to answer. And enter the hero of our story, the data warehouse. Its entire purpose in life is to break down those silos. It goes out, pulls data from all those different systems, and brings it together into one unified, trustworthy place. This creates what we call a single source of truth. It's what finally lets a company see, for example, which marketing campaigns are actually driving the most sales. Okay, so how does it organize all this data that was once a total mess? Well, it uses two main building blocks. First, you've got fact tables. These hold the numbers, the metrics, the what happened. So something like 50 units were sold. Then you have dimension tables, and these hold all the context, the who, what, where, and when. Who bought it? What was the product? On what date? These fact and dimension tables are then arranged into these really organized blueprints called schemas. You can really think of them as the architectural plans for your data. They describe exactly how all those different pieces of information connect to each other to tell one single coherent story. But, the world of data never ever stands still. The clean, structured world of the data warehouse was perfect for a while, but then came the flood of messy, modern data. Right, we're talking about all the unstructured stuff that businesses are swimming in now. Customer reviews, videos, social media comments, audio files. You can't just cram a YouTube video into a neat little row and column database. It just doesn't work. And this led to the creation of the data lake. Now, the huge difference is how they handle structure. A warehouse is schema on write. That means the data has to fit the blueprint before it's allowed in. A data lake, on the other hand, is schema on read. It's like a massive storage pool where you can just dump everything first, videos, text, whatever, and then you figure out the structure later on when you're actually ready to analyze it. So that brings us to today, and the rise of the data lakehouse. And it's pretty much what it sounds like. A hybrid approach that really aims to give you the best of both worlds. You get the massive, flexible storage of a data lake combined with the powerful structured analytics features of a data warehouse. Okay, so we've covered how data is processed and structured, but where does all this stuff actually live? Physically or, virtually? This brings us to a huge decision that every single company has to make. It's the great debate, on-premise versus the cloud. On-prem, as they call it, means you own the physical servers. They're sitting in your building or a data center you control. You have total control, but guess what? You also have total responsibility. Then there's the cloud, which basically means you're renting infrastructure from a provider like Amazon Web Services or Microsoft Azure. It's incredibly flexible and scalable, but you are relying on someone else. And what's the spectrum of services? A good way to think about it is like a ladder of increasing convenience. So let's climb this ladder. At the bottom you have IaaS, or infrastructure as a service. Here you're just renting the raw hardware, servers, storage, networking. Take a step up and you get PaaS, platform as a service. Now the vendor also handles the operating system and the development tools. And at the very top you have SaaS, software as a service. This is where you just use the final product. Think about Netflix or Salesforce. You don't manage any servers, you just log in and use the app. The vendor takes care of absolutely everything else. Okay, let's tackle the final, crucial piece of our puzzle. We've got all this great data sitting in our warehouse or a lakehouse, but data isn't static, right? It's constantly changing. People move, product names get updated. So how do we update our records without completely erasing the past? This is such a classic data problem. Let's say a company sold the Red Valley bike for 10 years straight. Now the marketing team decides to rebrand it as the Vibrant Valley bike. If we just go into the database and update the name, poof, all of our old sales reports will suddenly show the new name. And that's not right. We've accidentally rewritten history. So this challenge has a name. It's called a slowly changing dimension, or SCD for short. The simplest, most straightforward solution is SCD type 1. You just overwrite the old value with the new one. Red Valley bike is gone, forever. This is easy, and you might do it to fix a typo. But for a real change, like a rebrand, you've just erased your history. Now, SCD Type 2, this one is the historian's absolute favorite. Instead of overwriting, you add a totally new row for the updated value. And then you use start and end dates to show exactly when each version was the active one. Yeah, it's more complex, but it preserves the full, detailed history. This lets you accurately analyze sales under both the old name and the new name. And finally, there's SCD Type 3, which is kind of the compromise. You just add a new column to store the previous value, so you can see the current name and what the original name was. But if the name changes a third time, you lose that middle piece of history. So it's a bit limited, but it can be useful for a quick reference. So there you have it. From a simple click processed by a live system, to breaking down those data silos with a warehouse, to navigating the cloud, and then carefully preserving history. That is the modern data journey. It's this amazing process that transforms raw, messy information into a priceless asset. So the only question left is, what will you ask it to reveal next?
Okay, let's just say it. AI is changing everything, especially when it comes to data projects. So today we're going to break down exactly how that's happening and, what it really means for you as an analyst. Let's dive right in. I mean, it's kind of the big paradox of our time, right? We are absolutely swimming in data. Companies, organizations, they're collecting more information than they know what to do with. But all that volume, it's created this huge, huge challenge. All the data's there, for sure, but the actual insights, they're buried deep. And that's the real question, isn't it? That's the whole ballgame. How do we get from just having all this raw data to making smart, actionable decisions? Well, the answer isn't to just collect more data. It's about using a whole new generation of smarter tools to make sense of what we already have. So let's start by thinking about AI, not as this one big scary thing, but more like a brand new toolkit. A whole suite of powerful, specialized tools that are designed to help us cut through all the noise and find that valuable signal. Okay, first up in our toolkit is the one you've definitely heard about, generative AI. Now, for you as a data analyst, don't think of this as just a fancy calculator. Think of it more like a creative partner. This thing is a total game changer for, say, turning a boring spreadsheet of findings into a story that people actually understand, or summarizing super complex results in just a few seconds. What's really wild when you look at this timeline is just how fast all of this happened. I mean, think about it. In 2014, GANs popped up and suddenly AI could create realistic images. Just 3 years later, in 2017, the transformer architecture comes along. And that was the breakthrough. That was the thing that made these huge large language models possible. The ones that power the tools we're all using today. So, what's actually driving these language models? It's something called natural language processing, or NLP. You can think of it as the engine that lets a computer actually understand human language, not just the words, but the context and the feeling behind them. It's the reason an AI knows that when someone says, "not bad at all," that's actually a good thing, even with the word bad in there. This is the magic behind every chatbot you talk to. And this quote is just a fantastic way to picture how these models work. See, they don't know things the way we do. It's more like they've read a giant encyclopedia, but instead of memorizing it, they've broken down every single piece and just learned the patterns of how all those pieces fit together. So when you ask it a question, it's not giving you a fact it knows. It's just expertly putting the pieces back together to create what it predicts is the most likely, most probable answer. Okay, so if generative AI is great at helping us describe our data and tell stories with it, the next tool in our kit is all about predicting what's going to happen next. And this is the real powerhouse of AI, machine learning. So what is machine learning at its core? It's really about teaching a computer to learn from data on its own without us having to write code for every single possible scenario. And you see it everywhere. It's how your bank flags a weird transaction on your credit card, or how companies try to forecast market trends. The system basically just learns the patterns of what's normal, so it can immediately spot something that looks, well, not normal. Now, machine learning basically breaks down into two main types. First, you've got supervised learning. Here, you're the teacher. You feed the model data that's already labeled, like this is a fraudulent transaction, this one is not, over and over until it learns to tell the difference on its own. Then you have unsupervised learning. Here, you're more like a detective. You just hand the model a giant pile of messy, unlabeled data and say, find something interesting. And it goes off and finds hidden patterns all on its own, like maybe discovering totally new customer segments you never even knew were there. Yeah, I really like this quote because it just nails it. Supervised learning means structure. It means you are in charge, giving the model clear instructions and guiding it to the right answers with good, clean examples. And of course, it's not just those two. There are other methods. You've got semi-supervised learning, which is kind of the best of both worlds. A practical middle ground when you have a little bit of labeled data, but a whole lot of unlabeled data. And then there's reinforcement learning, which is a whole different beast. That's where an AI learns by trial and error, getting digital rewards for good decisions and penalties for bad ones. It's basically how you teach an AI to master a game. All right, tool number 3 in our kit is what I like to call the ultimate automated assistant. This one is all about pure efficiency. We're talking about robotic process automation, or RPA. And trust me, this is your secret weapon for getting rid of all that boring, repetitive work that just drains your day. RPA is pretty much exactly what it sounds like. You build a little software bot that is programmed to follow a very specific set of rules. The key here is that it's not about learning or predicting anything. It's just about executing a simple, predefined task perfectly every single time, like copying and pasting data from a spreadsheet into another system. So here's the absolute key difference you need to remember. RPA is deterministic. That means it just follows the script you give it, no questions asked, every single time. Machine learning, on the other hand, is adaptive. It learns from new data and can actually change what it does. So one automates a task, the other actually enables learning. And here's a perfect real-world example. Think about that weekly sales report you have to do. An RPA bot can be set up to do the whole thing for you. Step 1, it pulls the new data from the system. Step 2, it automatically refreshes the report. 3, it attaches that report to a pre-written email. And 4, it sends it out to everyone on the list. All of it done at the exact same time every week, and you didn't have to lift a finger. Okay, so we've got all these amazing, powerful tools in our new toolkit. Generative AI, machine learning, RPA. But this brings us to what is, without a doubt, the most important part of this whole equation, and that's you. Look, these tools are powerful, no question, but they are not perfect. They make mistakes, and that makes your single most important job, validation. You simply cannot just trust the output. You have to question everything. The data it used, the process it followed, and every single conclusion it comes up with. And here's a huge reason why that's so critical. These AI models learn from the data we feed them. It's the classic garbage in, garbage out problem. So if your training data is biased, or if it doesn't really reflect the real world, let's say it heavily overrepresents one group of customers, then the AI is going to learn that bias. Its results aren't going to reflect reality, they're going to reflect the flaws that were in your data to begin with. And then there's this other weird thing. AI is known to hallucinate. And yeah, that's the actual term for it. This is when a model just makes stuff up. It produces information that is totally wrong or just complete nonsense, but it states it with 100% confidence, like it's a fact. It's basically just filling in the gaps with what it thinks sounds right, and that can be seriously misleading if you're not paying attention. So look, using these tools responsibly is more than just following a checklist. It's really about a whole new mindset. You have to be paranoid about privacy, like never ever load proprietary company data into a public tool that isn't secure. You have to be a skeptic. Always double check the AI's output for accuracy and bias. And maybe most important of all, you have to be the strategist. The AI gives you a starting point, but it's your job to add that critical human context and tell everyone what it actually means. And that, right there, that is the key takeaway from all of this. AI is not here to replace the data analyst. It's here to make the analyst better. It takes care of the what, all the tedious data crunching, the pattern finding, the report building, and that frees you up to focus on the much more valuable questions. Why is this happening, and so what should we do about it? So I'll just leave you with this one thought. These tools are only going to get smarter and more powerful. So the real question for you isn't just how do I use these tools, it's how will I use them to push my own thinking to ask bigger, smarter, and way more important questions of my data. So how does a big jumble of raw, messy data get turned into a clean, powerful report that can actually change a company's direction? Well, it's not magic. It's a process, a journey, really. And right at the center of it all is the data analyst. Let's map out that journey together. You know, we always see that polished final product, the slick chart, the clear dashboard, but the real story, the adventure, is in that journey from chaos to clarity. The real magic is taking something that just looks like, well, nonsense, and finding the treasure hidden inside. And that, right there, is the whole idea for this explainer. We're going to frame this as a quest. You're the hero, and your mission is to find, tame, and totally transform data. Our adventure begins with learning to recognize our target out there in the wild. Okay, so your first challenge on this quest, identification. Data doesn't just walk up and introduce itself, right? It's usually in disguise, hiding in different file formats that totally control how you can work with it. Understanding these is absolutely the first step to mastering it. All right, the most common disguise you're going to run into is something called a delimited file. Just think of it as data that comes with built-in instructions. A special character, which we call a delimiter, acts as a divider. The most popular one by far is the CSV, or comma-separated values file, where every single comma is basically shouting at the software, hey, start a new column right here. And this is where you see the magic happen. Look at this. On the left, you open that CSV in a simple text editor, and it's just a wall of text and commas. It's a mess. But open that exact same file in a spreadsheet program, and bam, just like that, the commas do their job, and you get this perfectly organized table. That's the power of a proper file format. Okay, another key term you gotta know is a flat file. When you export data from some system, you're almost always creating a flat file. I want you to think of it like taking a photograph. You're capturing a snapshot of the data at one specific moment in time. It's static. If the original database gets updated 5 minutes later, your photo doesn't change. You have to go back and take a whole new one. Alright, so you know what data looks like out in the wild. The big question now is, where do you actually find it? This is the next stage of our quest, the great data hunt. Sometimes the data you need is already out there, just waiting for you to discover it. Believe it or not, there are these incredible public treasure troves of data just waiting for you. Governments often have to make their data public, so sites like the US Census Bureau are absolute gold mines for things like population data. And then you've got awesome community platforms like Kaggle, where you can find fascinating data sets for practice on pretty much anything, from machine learning to sports. The key is just knowing where to look. But of course, what's a good quest without a locked door, right? The treasure is locked away. You can't just download a file. You need like a special key or a secret password to get the data you need from another piece of software. And that's where this brilliant little thing called an API comes in. Honestly, the restaurant analogy is the best way to think about it. You don't just barge into the kitchen yourself to get your food, right? No. You give your order to a server, that's the API, who then goes to the kitchen for you and brings back exactly what you asked for. It's how different software systems can talk to each other and share data in a really controlled, orderly way. So, what happens when you've searched everywhere and the data you need just doesn't exist? Well, a true analyst doesn't give up. No, they forge their own tools, and they create the data themselves. This is a really big moment in any analyst's journey. This is where you stop being a hunter and you become a creator. And one of the most powerful ways to create original data is through surveys, literally just asking people for the information you need. Now, making your own data from scratch might sound like a huge, daunting task, but you can actually break it down into these 4 pretty clear steps. It always starts with one focused question. From there, you design your survey, you figure out exactly who you need to ask, and then you just go out and collect the responses. It's a very methodical process of creation. And when you're designing it, every single word matters a lot. Just look at this question. How awesome was your customer service today? See that? The word awesome, that's a leading question. It's already nudging the person towards a positive answer. This kind of thing creates biased, totally unreliable data. A great analyst knows that crafting neutral, super clear questions is absolutely essential. Okay, awesome. You've found your data. You might have even forged some yourself. So now you have your raw materials. But you can't just leave them lying around in a pile. You need a secure, organized place to store everything. You need a vault. Well, in our world, in the world of data, that vault is called a database. And inside, you have these super organized strong boxes called tables. This is where your data is going to live, all structured with neat rows and columns, just ready for you to access and analyze it. So, how do you actually build this vault? Well, you use a language like SQL, and there are 3 really basic commands to get started. Create is your command to build a brand new table. Alter lets you modify one that's already there, maybe add a new column or something. And drop, yeah, that's the big red button. Use it carefully because it deletes the whole thing for good. These are your foundational blueprints for storing data. All right, we are getting close to the end of our quest. You've acquired the raw data and stored it safely. But think about it. When you find raw gems, they're not ready to be put in a crown, right? They're dirty, they're rough, they need to be cut, cleaned, and polished. And this is the final and maybe the most important stage. And that's the thing about raw data. It is always messy. It's got errors, typos, weird formatting, missing values. It's a mess. The transformation from that raw material into a valuable asset is where the real work and the real magic happens. So, this whole polishing process has a name. We call it ETL. It stands for extract, transform, and load. First, you extract the data from wherever it lives. Then comes the crucial transform step, which is where you clean it, reshape it, and get it all ready. And finally, you load that polished, analysis-ready data into its final home, like a data warehouse. But of course, technology never stands still, right? So there's a modern twist on this called ELT. Extract, load, transform. Notice the difference? The L and the T are flipped. Here, you load all the raw data into a flexible storage system first, and then you transform it later as you need it. This is super common with massive data sets in what we call data lakes. And when we talk about that L, the loading part, there are really 2 main ways it happens. The very first time, you do what's called a full load. That's moving every single piece of data over. But after that, you usually do delta loads, which are way more efficient because they only bring over what's new or what's changed since the last time. And after all of that, the hunting, the forging, the building, the polishing, you finally arrive here. You've taken all these different files and API calls and survey results, and you've brought them all together into one single, cohesive, powerful data set. The quest is complete. Your data is ready. This whole process, the ability to turn raw, messy information into a powerful insight, that is a serious superpower. So, now that you know the path, there's really only one question left to ask. What question are you going to answer first?
All right, let's talk about data. If you've ever been in the trenches with it, you know the truth. It almost never shows up looking clean and perfect. No, it's usually a mess. Incomplete, inconsistent, you name it. But what if there was a way to take that raw, messy stuff and turn it into something genuinely valuable, like a kind of digital alchemy? Well, that's exactly what we're diving into today. You've heard this one before, right? It's the oldest rule in the book for a reason. Garbage in, garbage out. It's so simple, but it's the absolute truth. If you feed your system bad information, you can't be surprised when you get bad reports, bad predictions, and ultimately, really bad decisions. It's the foundational problem everyone in data has to solve. And that's the big promise here. That's what this is all about. The whole process of data quality control is about catching that garbage before it messes everything up. It's how we refine it, clean it, and make sure the information we're basing huge decisions on is trustworthy, accurate, and ready to give us some golden insights. So, here's how we're going to break this down. First, we'll dig into the garbage in problem, why it's such a big deal. Then, we'll get specific on what high-quality data even looks like. After that, we'll clear up the difference between validation and verification, super important. And finally, we'll run through the actual playbook analysts use to get it all done. Okay, let's start with the why. Why does this matter so much? Because bad data isn't just a small technical glitch. It has real, tangible consequences. It leads to reports that are flat out wrong and can send a company confidently marching in the completely wrong direction. So where does all this messy data even come from? What's kind of funny is that bad data doesn't come from some rare catastrophic event. It happens because of totally normal everyday business stuff. Two companies merge, and now you have to smash their totally different data systems together. Someone's manually typing in customer info. Hello, typos. Even just moving data from one system to another can corrupt it. It really is a constant battle. And this brings up a really key point. Data quality isn't about being 100% perfect all the time. That's usually impossible. Instead, organizations set goals based on what matters most. For instance, getting customer emails right is probably crucial for marketing, so they'll aim for something like a 95% quality score. But, maybe having a perfectly accurate physical location for every single customer is less critical, so 80% is good enough. It's all about strategic priorities. So we know why we need good data, but what are we actually aiming for? What does good data even mean? It's not just a feeling. There are actual characteristics we can measure. Let's break down the anatomy of what makes data truly high quality. We can really boil the whole concept of quality data down into 5 main dimensions. You can think of these as the 5 pillars that have to be in place for any data set to be considered trustworthy. First up is completeness. This one's the most basic question you can ask. Is all the information there? If you have a customer record, but the email field is empty, well, you can't email them, can you? That record is incomplete, and its value just plummeted. A single missing piece can make the whole entry useless. Next up, accuracy. This means the data actually reflects reality. Let's say your company just renamed a product from the Red Valley Bike to the Vibrant Valley Bike. If your database still has the old name, it's not accurate. And see, the data might be complete, the field isn't blank, but if it's the wrong information, it's just as bad, if not worse. Then we have consistency. Oh, this one is a huge headache. Is the data formatted the same way everywhere? Think about state abbreviations. If you want to find all your customers in Maryland, but your data has MD, MDOT, and MD, a computer sees those as 3 totally different things. Without a consistent standard, you can't possibly do a reliable analysis. Our 4th pillar is timeliness. And this is so important because data gets stale fast. If you're trying to decide what to restock today based on sales numbers from last week, you're basically flying blind. Data that was accurate a week ago might be completely irrelevant today. For data to be good, it has to be fresh enough to matter. And finally, uniqueness. This is all about killing the clones, getting rid of duplicate records. If the same customer is in your database 3 times, your customer count is wrong, your sales per customer is wrong, everything gets skewed. And you can see how all these pillars work together. A lack of consistency makes finding those duplicates almost impossible. They all support each other. Okay, let's get into a really important distinction that honestly trips a lot of people up. It's the difference between data validation and data verification. They sound super similar, I know, but they do 2 very different and very important jobs. So data validation is all about checking the structure and the format. It basically asks, does this data look the right way? A perfect example is checking an email address. A validation check doesn't know if john.smith@email.com is a real inbox. It just checks that there's an @ symbol and a .com at the end. It's a rules-based check. Verification, on the other hand, is the truth squad. It's all about checking for accuracy. It asks, is this the right value? So in this example, the price, $50, might be a valid number format, but a verification check would flag it and say, whoa, hang on, all the other products are $10. Is this one really supposed to be 5 times more expensive? It's a reality check. So let's just nail this down. Validation checks if the data is in the right shape. For example, does this postal code have 5 digits? Verification checks if it's the right value. Does that 5-digit postal code actually exist for the city that's listed? You absolutely need both. One without the other is just a false sense of security. Okay, we get the problem. We know what good data looks like, and we know the difference between our 2 main checks. So, how do analysts actually put this all into action? What do? Let's open up the quality control playbook. Well, analysts have a few key methods in their toolkit. They often start with data profiling, which is like getting a bird's eye view of the data to spot any weird patterns right away. Then there's reconciling. This is huge. It means making sure the sales numbers from the marketing system actually match the revenue numbers from the accounting system. And you can't forget peer review, the good old buddy system. Having a second pair of eyes on your work is priceless for catching mistakes you've been staring at for hours. And of course, they're not doing all this manually in a giant spreadsheet. There's an entire world of powerful software out there to help. Tools like DBT and Great Expectations are like having automated guardrails for your data, constantly running tests and flagging problems. And things like Power BI with its Power Query engine can help you clean up data right as you're loading it in. These tools are what make data quality possible at a massive scale. So if you remember one thing from all of this, let it be this. High quality data never ever happens by accident. It's a conscious, deliberate process of checking, cleaning, and refining. It's the hard work you do up front that builds trust in every single number, every chart, and every decision that follows. And that kind of leaves us with a final question. The next time you look at a polished dashboard or a final report, I hope you'll see it a little differently. Will you stop and wonder about the incredible journey that data had to take, from its raw, messy, garbage state, all the way to the clean, trustworthy, golden insight that you're seeing on the screen?
You know, every single data project, whether it's big or small, it lives or dies by one simple rule: the quality of its foundation. So today, we're going to break down that essential first step, turning all that raw, messy information into a clean, trustworthy asset, the kind that actually leads to those powerful insights we're all after. I'm sure you've heard this saying before, and honestly, it's the golden rule for a reason. If you start your analysis with flawed, messy data, you can bet that your results, your reports, and any big decisions based on them, they're going to be flawed too. It's as simple as that. And that's the core problem we're here to solve. So why is our data so messy in the first place? Well, this analogy just nails it perfectly. Think about it. Most companies are constantly changing. Business needs shift, new software gets bolted on, processes get updated on the fly. And the data systems, they're always playing catch up. It's not about anyone doing a bad job, it's just the reality of a dynamic, growing business. Okay, so here's our game plan. We'll start by really digging into the common causes of messy data. Then we'll move on to profiling. Think of it as our diagnostic tool. After that, we'll open up the cleansing playbook, and finally, we'll wrap up with that crucial last step, data conversion. All right, let's get right to the root of the problem. Because understanding why your data is dirty, well, that's the absolute essential first step before you can even think about cleaning it up. A lot of these imperfections are just a natural byproduct of how businesses run, you know? You might be pulling data from totally separate sales, marketing, and finance systems. Or hey, someone could just make a simple typo during manual entry. It happens. Or maybe a business rule that made perfect sense 5 years ago is now totally obsolete. The point is, pretty much all raw data needs a solid checkup before you can trust it. So now we know why data gets so messy. How in the world do we start to fix it? Well, you wouldn't treat a patient without a diagnosis, right? That's where data profiling comes in. It's our data x-ray. And to be clear, this isn't about fixing anything. Not yet. It's all about getting a clear, honest look at the true state of our data. Profiling is really the foundation for everything that comes next. It's how we systematically check for quality, completeness, and accuracy. We're asking really basic but crucial questions like, what's actually in this data? How much of it is there? And honestly, does any of this even make sense? And this is your practical go-to checklist for doing just that. You start by figuring out where the data came from, you check the data types, are your dates actually stored as dates, or are they just plain text? And you always, and I mean always, count your records. For example, if you start with 25,000 rows of data and you end up with 24,000 after moving it, profiling is what helps you catch that data loss right away. Okay, diagnosis complete. Now it's time for the treatment. We're opening up the Data Doctor's Playbook to handle some of the most common issues you're going to find in your data sets. First up is a really, really important distinction: redundant versus duplicated data. See, redundant data means you have the same product list living in two different systems. That creates a source of truth problem. Which one is right? But duplicated data, that's when a single record shows up over and over again in the same file. And trust me, that can be way more dangerous. And here is why. Let's say one single purchase order for $500 has 3 different items on it. In the raw data, that one order might show up as 3 separate rows. So if you're not careful and you just sum up the sales column, you'd report $1,500 in sales instead of the correct $500. That's not just a reporting error, that's the kind of mistake that could lead to you blowing your marketing budget or making completely flawed inventory decisions. Okay, on to the next common problem. We've all seen them, those blank cells, the empty fields. So what do we do about these ghosts in the data? You know, the null values? Now here's a key insight. A null value isn't always a mistake. In fact, it can be incredibly informative. A null in a ship date column, that probably just tells you an order hasn't shipped yet. A null for a product's color, it might just mean that product doesn't have a color, and that's okay. The key is to investigate why a value is null before you decide what to do with it.